In this video, we can solve one more problem on velocity diagram by using relative velocity method. Let's see here. First, we can calculate what is the linear velocity of link OA, which is the crank in this case. Velocity of link OA is equal to OA into 2 pi n, which is 120 rpm by 60. Here OA length is 150 mm. 150 into 4 pi, which is equal to 1885 mm per second. Again, take the scale. My scale for this problem is same. 1 centimeter is equal to 100 mm per second. Or you can take 500, okay, as per your convenience. That means for 1885 mm per second, it will be 18.9 approximately centimeters. Now we can draw velocity diagram for this problem. Here, this is the fixed support. Let us take that as a 0. Now draw velocity of point A with respect to O. Now here the velocity is, it is rotating in a clockwise direction. At this position, the velocity of A is like this. Now draw a line perpendicular to OA. This line length will be according to your scale. Now once you can get point A, draw a line perpendicular to AB, that means AC. Draw a line from point A. Now if you see here, velocity of the slider is moving along 45-degree line. You can take fixed point and draw that 45-degree line. This will intersect at this position. This point will be C. Now identify the point P, B based on the ratios AB upon AC, which is equal to AB upon AC. AB in this case 500, AC 500, AC is, sorry, AB is 300. AB is 300 and AC is 500. Now measure AC according to your drawing. Please check. In this case, it is approximately 1.3. According to that, you can calculate AB value. Now that according to that measurement, you can take B somewhere comes here. Now once you can get point B, draw a line perpendicular to BD. This is a line perpendicular to BD. Now D is the slider, it is moving in y direction. Now draw a line perpendicular to that, sorry, parallel to that. The intersection point will be D. Now erase, sorry, this is O, D. Okay, this is the velocity diagram. Now, what are the things that we have to find? Velocity of linear velocity of C and D. Velocity of slider C is equal to measure the length of OC into scale that you have considered. Similarly, velocity of D, you can measure OD length, that means this, into multiply with the scale, that will give the velocity of slider D. Similarly, how to find out angular velocities of link AC and BD? The angular velocity of AC is equal to linear velocity of AC upon length AC. AC into scale AC into scale upon AC length. AC length means this is the AC length. AC, small AC will be, this is the length. Scale is, this is the scale. That means 100 mm per second. In a similar manner, omega BD. Omega BD is equal to velocity of BD upon length link BD. BD into scale upon BD. BD means this length from here to here. Measure it and multiply with the scale and BD length. Now we can see another problem. If you see here, they given different velocities, different links and their length. First you have to construct this space diagram. Then here the crank of this image or given mechanism is, now AB is rotating in a clockwise direction. AB is rotating in a clockwise direction. That means velocity of B will be in this direction. What is the velocity B with respect to A? Link length AB and omega AB. What is the speed? Angular velocity 60 rpm. That means AB length is 60, 2 pi n by 60. That means 2 pi 120 pi. Which is equal to 377 mm per second. Again, I will take similar scale which we have to consider in the previous problems. 1 centimeter is equal to 100 mm per second. For 377 mm per second is equal to approximately 8 centimeter. Okay, now in this given mechanism, A and D are the fixed points. Now let's see how to draw velocity diagram. Now first start with fixed point. Let us take A comma D. This is a fixed point. Now draw a line perpendicular to AB. Draw a line. This is perpendicular to AB and the length will be 3.8 centimeter. This point will be B. Now after that, take a line perpendicular to BC. From point B you can draw a line perpendicular to BC. And here we don't know the point C point, but we know the D point. Now draw a line perpendicular to DC. From point D, draw a line that will intersect the previous line. That point will be C. Now in this case, CDE is the one link. That means it is a CDE one link. Now you can draw here CD and DE are 90 degree to each other. Now you have to draw a line perpendicular to the AC. This is 90 degree to each other. Why? Because here it is a same link and CD and DE is 90 degree to each other. Now I draw a line perpendicular to that. Now what is the CD distance? Sorry, DE distance. That you have to calculate from the ratios. That means capital CD upon DE is equal to small cd upon small d. You can measure what is the length of this CD. First you can measure this, use that value here, and similarly measure the length here. Okay, here I am assuming this length will be x, this length will be y, which is equal to CD. That means measure this length. Let us take this is Z. From that you can calculate DE value. DE value will be ZY upon X. You can measure what is the Z value, X value and Y value from your drawing. According to that you can measure what is the DE distance. Let us take, I am assuming that based on your calculation you may get point here. Once you can get point E, draw a line perpendicular to EF. Draw a line perpendicular to EF. I draw a line. Then here F is the slider. Slider always move either vertical or horizontal. Now this intersection point will be F. Okay, this is the velocity diagram for given diagram. Now how to calculate the velocity of slider F? Velocity of slider F is equal to the length of AF, that will give the, multiply with the scale, that will give the velocity of slider F. In this manner you can calculate velocity of any given space diagram or mechanism.